example of a rational root theorem. So I have different factors now, and if you look at my last example, the numbers were just 2 and 2 on the other video. Now we're gonna have a tougher number, 8, because 8 has a lot more factors and a lot more different possibilities. So I have x cubed minus 8x minus 8, and the rational root theorem tells me that there is a rational root, okay, if one of the factors of p, the integer factors, is over the integer factors of q. So you see all the factors of p. For 8, you have what? Plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, right? Those are all the factors of 8 there are for integers, okay? So for q, the coefficient of here is 1, right? So the only possible factors of that is just 1, positive 1, and negative 1, right? So these are all the different combinations of possible rational roots for this equation. So let's start off, let's try 1. Let's try something easy, okay? So again, we use synthetic division because that's the quickest way to find the remainder. And the remainder is 0, that means that's one of the roots. So let's copy it down. I picked this one problem because if you see here, there's missing an x squared. So what happens when you're missing x squared? You have to put it in a 0. Okay? So this is synthetic division that we're doing right here. And you see it, if I'll make a video for synthetic division, but I'll go over it very, very quick. So you copy the coefficients down. So 1 is here. 0, the reason why I have 0 is 0x squared. So I'm accounting for the x squared. And negative 8 is for the x, and negative 8 is for here. So you copy the coefficients down, and then now we do synthetic division. And our goal is to make sure the remainder is 0. If the remainder is 0, that means that's one of the rational roots. So let's try 1 to see if it's a rational root. There's a lot of trial and error involved, so let's start. Okay, so 1 plus nothing is 1. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. Negative 8 times negative 8 plus 1 is negative 7. And then 1 plus negative 7 is negative 6, and you can see it's no bueno, negative 14. So we know 1 is not one of the solutions. So let's make a list. 1, no good. Let's make a no good section here. So that's the no good box right now. 1's no good. So let's try a different one. How about let's try negative? Let's try 2. How about that? We'll try 2. I just feel like trying 2. You can try any of the factors of combinations, but I just feel like trying 2. It's all luck. I mean, you can kind of estimate where it's going sometimes. The number is getting really, really big, so maybe you should try a smaller number sometimes. Okay, so let's try that. 1 comes down. 2 times 1 is 2. 0 plus 2 is 2. 2 times 2 is 4. Negative 8 plus 4 is negative 4. 2 times negative 4 is negative 8. Oh, so close. Look at that. Almost 0. Okay, but it's negative 16, unfortunately. So 2 is no good either. Okay, so let's try negative 2. Maybe that'll do something. So let's try negative 2. Okay, that's one of the possibilities. Negative 2 over 1. Okay, so negative 2, 1 down. Negative 2 times 1 is negative 2. 0 plus negative 2 is negative 2. Negative 2 times negative 2 is 4. Okay, negative 8 plus 4 is negative 4. Look at what we have here. Negative 2 times negative 4 is 8. Negative 8 plus 8 is 0. That means that 2 is one of the roots. Okay, so we know that x minus 2 has to be a factor of this because of that. Okay, I don't know if hopefully that makes sense. Okay, that means x minus 2 is a factor of x cubed minus 8x minus 8 if negative 2, actually wait a minute, x plus 2, sorry. X plus 2 is a factor of x cubed minus 8x minus 8. Okay, because negative 2 is a root, so therefore x plus 2 has to be a factor of x cubed minus 8x minus 8. Okay, if you have questions, please ask. So now we know that negative 2 is a root. So now the remaining, if you put x plus 2, you'll get this. 1, negative 2, negative 4, so you can rewrite it as x squared, is 1x squared minus 2x minus 4 equals to 0. Okay, this is what you have remaining. And we know there are 3 roots for this equation. Okay, one of the roots we know is negative 2 now. So let's solve this. So we have x squared minus 2x minus 4 equals 0. Well, let's solve this. For me, the easiest way I would say is completing the square. I mean, for this one. So let's put 4 on the other side. Okay, I add 4 on the other side. And let's complete the square, and to complete the square is half of the b, which is 1, right? Negative 1. And then square it, so you add 1 on both sides. I'll make a video for completing the square and synthetic division. I know I have so many math videos to make to explain all of these. So 4 plus 1 is 5, and then I just factored x squared minus 2x plus 1 is x minus 1 all squared. And I can take the square root on both sides, okay, and then you get root plus or minus 5, and I add 1 on both sides, so you get 1 plus or minus square root of 5. So the solution will be x equals to 1 plus or minus root 5. Oops. Let me write my 5 a little more clear. 5, okay? And then 2. Negative 2, I mean. Negative 2. Okay? So that's my solution to this x cubed minus 8x minus 8 is 1 plus or minus root 5 minus negative 2. Now, one thing you notice is that negative 2 is the only rational root in this whole solution set. Okay? There's 3 roots, but only negative 2 is the only rational root. How come? Well, radical 5 is irrational, isn't it? So there's no way you can find this root as a possible solution since it's 1 plus or minus root 5. Root 5 is an irrational number. So remember, rational root theorem is to find all the rational roots only. You can't find any other roots other than rational. You can't find irrational roots with this. So negative 2 is the only one you're gonna find that works with this theorem. Okay, so I hope this helps answer a lot of questions. It's it's one of the chapters that a lot of people forget in Algebra 2. It's usually taught. If you have any questions, please put comments, send emails, whatever you need to do. I hope this helps. Thanks.